Okay, as a reminder, I am recording this session. You can feel free to mute yourself and go off of video if you're not comfortable with that. But we just want to make sure that everybody who's here can refresh their memory later or send it on to colleagues who need the information. This is session 7 in our series. We have gotten through most of the equipment types already as far as the WHO commodity package is concerned, but we know that there are still a lot of remaining questions about a lot of these devices. So we're going to go back through these one by one, and we're starting with ventilators today. And we'll just address some of the questions that you guys had, that some of our other participants have had in Africa. And we'll go in more detail with the very specific troubleshooting things that people actually need to see. Again, this is all based on feedback that we get through polls and through emails and through surveys. So please make sure you're sending us any feedback that you have so that we can continue incorporating that into future sessions. Again, if you're new around here, don't forget that this is a conversation based on love and respect. We want to keep this a safe space to have discussion. Please test your equipment ahead of time and mute your microphone when you're not speaking. That's in the bottom left-hand corner of your screen. Also remember to unmute and introduce yourself before speaking once we get to our discussion. If you're in a large room, go ahead and stay very close to your microphone so that we can hear you. And if you have any issues at all throughout the session, you can go ahead and either chat us in this program or you can email us here. Today, Kuna is going to give us a didactic about ventilators, and we'll also look through some case studies from our friends in Ethiopia. And with that, I'm going to turn it over to Guna.
Hi, everyone. So we're going to talk about ventilator details today. So first thing we need to, based on certain things, you need to know your mode of ventilator. So you got control ventilator, control mechanical ventilator, CMV, then assist control, synchronized, mandatory, and continuous positive pressure, CPAP. But there's a lot of other controls that depends on the model of your ventilator. So these are one of the part of the model, what the modes that you're going to see. And when you talk about control mechanical ventilator, it can be volume pressure, a volume control, or pressure control. So when you talk about volume control, ventilator deliver with fixed tidal volume and with a respiratory rate. So that's for volume control. Pressure control is delivered tidal volume and presence of pressure depend on the lung condition. So these are the two types that you're going to normally see on ventilator. So when you talk about assist control, it can be mode that provide breathing with either tidal volume or peak pressure. Depends on the type of the condition of the patient. And that's a synchronized as well, SIMV. So these are patients are guaranteed with the volume or pressure, but at the same time, it will trigger according to the condition of the patient itself. If the patient going to trigger something from their breathing, it's going to help to support that particular breathing as well. So that's how it works on the SIMV. So VCV is normally referred as volume control ventilator. PCV is pressure control ventilator, but the terms can be changed, depends on the brand, but the function is almost similar actually. So when you talk about parameter for ventilator testing, there's always, you need to remember when you talk about ventilator, the incoming pressure is very important. The pressure should be somewhere 4 bar to 6 bar. Normally it's 450 kPa, kilopascal to 680 kilopascal incoming pressure. So if you are using cylinder, you need to have a regulator to step down the pressure and is go to the ventilator unit. Or if you're using centralized gas system, your centralized gas system normally somewhere between 4 bar to 6 bar. So you need to look into that. And make sure check the line as well. And when you do ventilator testing, make sure that you do self-test verification. Very important. Self-test verification, verify the sensor, the leak test, all that, and check is it passed during the verification. Once it passed, you have to go to setting the tidal volume, respiratory rate, and positive and expiratory pressure P. Depends what setting you're using, but if you ask me, I'll run on the volume rate and set certain things and see the output. So you have to check all this, then IE ratio, the alarm as well. So that by doing this all, by setting the values and setting the rate of respiratory and PEEP, all this, and you can do the testing by using the analyzer. So if you see on the parameter of ventilator testing, on the checklist part of it, there's a, you need to do O2 failure alarm by removing, by stopping the oxygen on the incoming to ventilator, or air failure alarm, all that you turn off. You can check if the ventilator giving alarm or not. Then check the breathing leakage. These are one of the old method to use, but you can do the self-test. When you do the self-test, if pass, just put the reading as a pass. And at the same time, you can do O2 calibration, the 21 and 100% during the self-test. If pass, just put pass and set the tidal volume, like for example, 300, then the breath rate 12, then O2 you can set 21, and the PEEP and IE ratio, and see the reading. Is it inside the range? And you see the, you can see the limit and tolerance that have been set. So you need to be in that range. If it's 300, it should be somewhere 270 to 330. Remember, all these measurements are based on 10% NIV, non-invasive ventilator. Driving gas change step. These are one of the questions that one of the engineers, how to do this for anesthesia if they want to convert them into ventilator, but want to run it with a different driving gas. So the O2 air pipeline manifold have driving gas connection at the back. Okay, these are based on GE device. The connection not in use to plug. So at the back of the unit, when you remove the cover, there's a connection thing. So you can see, remove the back cover, then you can remove the plug from the new connection. You can see the O2 line connection, and disconnect the driving gas hose, the black hose, from the present connection. Install the plug in the connection and pull on the plug. Ensure that lock into the fitting. Okay, and reroute the driving gas hose and make sure it's not kinked. Do the connection properly and connect the driving hose, a new connection. Pull on the hose connection. Ensure the lock into the fitting. So make sure you fit all that. Then you do the high pressure leak test. Then enter the service mode and do the corrective driving gas setting. So you have to go to the service mode, change the driving gas setting. Okay. Then and test the primary regulator, verify its function and specific the supply driving gas of the ventilator, and perform the self-test or checkout procedure. If everything okay, then you can start to use. So this is one of the things that you can do if you are changing your driving gas on anesthesia machine. Okay, and some people ask question about single limb and dual limb. So when you talk about single limb circuit, use circuit normally they use for pressure trigger volume ventilator, and minimum amount of circuit that base need to be there between the mass and the acceleration of a valve using a single limb reading. Short circuit, less resistant on the circuit, need to use HME filter. And very important when you talk about single limb, there's a aerosol issue with single limb due to the exposed near end of the circuit of expiratory out. So if you are expiratory, you have to remember when single limb, you're getting inspiratory line, but expiratory going to be exposed on atmosphere. So you need to be careful when you're doing single limb. If the patient is COVID, there's a probability of aerosol spread. So you need to do a filter, make sure there's a filter attached. So that will be a protection from aerosol. That's single limb part. For dual limb, circuit can be used on the both pressure triggered and volume triggered ventilator, and is have minimal dead space, reduce pollution on and no exposure with the filter, because you can see on this particular line, on inspiratory, you can have a Y connector filter, and you can have another filter at expiratory line. So it's more controlled actually. And you can use convection heat and moisture. And end of the day, expiratory tube meet at the Y connection, and few centimeter pass through the patient single tube. So it come back as a single tube, but when they meet on the Y tube, there's an inspiratory circuit and expiratory are linking together. So these are how the single limb and dual limb look like. When you talk about dual limb, you got inspiratory line, expiratory line, then a single limb system circuit. If you see on the ventilator and patient circuit type, on the single limb system, there will be a expiratory valve and inspiratory valve, but the inspiratory line is one way, and the expiratory using a small tube that doing the measurement. And at a single limb, that's another way, intentionally leak expiratory line. So what happens is you breathe, but at the same time there's a leak. Normally, if you see this type of concept, they use in CPAP. Testing ventilator. When you talk about testing ventilator, so on testing ventilator, okay, let me go through the ventilator patient circuit type. There's a expiratory line and inspiratory and Y circuit. This is normally you can see. And single limb, there's a expiratory valve. And inspiratory type with the expiratory exposed. So this is circuit that you normally see. And on testing ventilator, the placement of ventilator analyzer is similar to a proximal sensor. Some ventilator, you can add on a proximity sensor at the end of the breathing circuit. So it's on the Y connector, you can have a proximity sensor to measure the overall. And you have to remember, when you talk about a proximity sensor near to the Y connection or near end to the patient, your ventilator should have that capability of connecting this particular device. So that's the reason when you do testing on ventilator, you are using your ventilator analyzer at this particular point, at the Y point, and at the end of inspiratory line for single limb, because you want to know the total NIV, non-invasive ventilator output. So that's the reason you are doing this. And when you talk about ventilator and ICU, normally the testing mode set at BTPS, body temperature, pressure, saturation. The reason is going to, because of the body temperature, all that, is going to calculate based on that flow. And at the end of the day, you're going to measure IE ratio, VTI, MV, volume, all this. So this is the correction for Y type. Even the proximity sensor, they use for this particular measurement to get all the information actually from the endpoint, because between the ventilator and the circuit, there's a 10% NIV, plus minus. So you want to get an actual reading near to the patient, you need to have a sensor there. That's the reason you do, by using ventilator analyzer, you're doing this same method. And for, if you see on the single limb part, single limb test configuration, so you can see ventilator, then single limb tubing going to the ventilator analyzer and test lung. Always remember, your test lung play a very important role, because you need to have some certain pressure to test. So you need to have a 1 liter test lung for adult and 500 ml test lung for neonate. And calibration oxygen sensor is very important. You're going to calibrate 21% atmosphere and 100% from the oxygen supply. It's good to do calibration, because sometimes what happens is the lifespan of this particular sensor is somewhere 18 months to 1 to 2 years, depends the usage as well. Make sure you calibrate and make sure test. If the calibration fail or you change sensor and your calibration reading is not good, compare with another oxygen analyzer, because sometimes what happens is if you are using centralized system, if you don't monitor your centralized, maybe you ended up going to get a low oxygen incoming. So it's better to have another oxygen analyzer to verify this. So always remember, after replacing oxygen sensor, you need to calibrate the sensor. The reason is when you plug in a sensor, maybe it'll show you 21, and the oxygen will, when you run the oxygen 99, you get 97. You think it's good, but actually you need to calibrate the milliwatt of the oxygen back to the actual configuration. So that's the reason when you change the sensor, you calibrate the sensor to make sure it's work properly. Because sometimes when you do, you put your oxygen 99, but it will show 97. That that maybe look good, but sometimes what happens is when your oxygen setting is 99, but it's going to show 100 above or error. So it's always remember, when you change your sensor, you calibrate as well. Okay, for clinical user, this is very important. This should be a daily routine that clinical user have to do early morning before they use it on the patient. Okay, this is based on the step from the GE Cascade R860 quick reference guide. So when you, as a user, some issues are beyond technical thing, because before you want to apply on the patient, you need to know your ventilator is working properly or not. So always make sure that you test your ventilator before you apply on the patient. So you need to have certain tools, not analyzer, all that, but with a simple verification is good enough already. Okay, before powering up, connect your inspiratory safety guard, exhalation valve, all this, and the breathing circuit properly. And before you power up, connect your air oxygen supply into the outlet and power on the unit. Once you power on unit, there will be a new patient setup, all that. Key in certain things and try to run the performance check, the self-check system, and see whether all the self-test is passed. Then use the test lung to run a normal basic test, like 500 ml, PEEP, all that, and see is it inside the range or not. So run a basic test, all that. Once you've done that, the machine is ready. So set on the mode backup, all that. Keep the machine ready for a patient. This is what you have to do every day. Every day and every time a patient going to start use ventilator, before that, you need to do this type of verification. So by doing this, you know your ventilator is ready to use on the patient. So this very important for clinical user. Because I seen experience that this we get complaint from clinical user telling the machine is not working properly, all that. But what happened is they don't do verification earlier to see the self-test whether pass or not. So eventually what happened is patients struggle to breathe, all that. So it's very important to do early morning verification and before use it on the patient. And common error and troubleshooting. It's very common that you're going to see system leak, circuit malfunction or disconnect, inadequate oxygen and alarm, improper ventilator support mode, triggers sensitivity, flows issues, cycle PEEP issues. Okay, these are very common error and that you're going to see. So to make sure things don't reappear again, always make sure do self-test regularly by using self-test mode. Follow the instruction on the unit. The reason you do self-test, you can verify whether the system got leak or not. Because most of the new generation ventilator, they have self-test. But those days, we need to do certain connection and you have to run the system. It's a bit different, but the new generation of ventilators, they are very good actually. They have the self-test that can do verification, all that. So always check with the self-test method by using test lung, verify if the circuit is working. It's very important. Verify oxygen purity by using oxygen analyzer. With ventilator, you can see the oxygen output, but at the same time, always verify your centralized system is working properly. Because I seen a certain place that I visited, the user said the oxygen is 99, but ended up you got 78% on the centralized system. So it's better to have oxygen analyzer to verify the output as well. And check the cylinder pressure. What happened is some countries that I got experience, they don't have medical grade regulator. So what happened is they try to use industrial grade regulator. An industrial grade regulator can go up to 12 bar. So what happened is your medical equipment ventilator only work from 4 bar to 6 bar. So when they use industrial regulator, they ended up going to use somewhere 7 bar, all that. So your regulator, high pressure regulator, going to make a whistle noise or high pressure alarm. So you have to be careful with that. You can damage the particular regulator as well. So make sure you do all this testing, and if all the modes working properly, verify using test lung, then you can apply to the patient. This is what normally a user going to do, even a biomedical engineer going to do when there's a problem. You're going to check all these, the 4 steps, but applying on patient is not a biomedical work. Always remember, it's a user's thing, but at the same time, make sure you refer to the manual. User manual play a very important role because each model, they got their own way of doing method testing, and each brand, they got their own way of doing. So you need to know by the model and the brand, and try to get the user manual, get to know the ventilator, all that. Flow sensor, another common error. Cannot read oxygen flow sensor, cannot read exhalation flow sensor. So this is another thing. Sometimes you don't get inspiratory reading, all that. So enter to diagnose mode, check, depends on the brand and model, verified what's going on with the flow, verified the oxygen flow sensor, cable connection, replace, or another important thing is calibrate them and see whether it's working or not. And sometimes you ended up going to see a moisture on the circuit. That can cause the reading is not stable. Sometimes you're going to get very low reading. Sometimes you're going to get very high reading. Depends on the type of sensor. Some are using one line hybrid sensor. Some are using turbine type to measure. So you need to know what type of sensor you're using. Gas supply source, lack of supply or incorrect regulator pressure. So these are very common things that I see. So when you talk about this type of issue, normally preferable is to have a centralized gas supply, but we understand some places you don't get this centralized system because it's too expensive. If you're using cylinder, make sure the cylinder is always full, and always keep a separate cylinder extra, and check the cylinder pressure on centralized if it's inside 4 bar or 6 bar range. That's for centralized. But if you are using a cylinder, check the regulator is inside 4 bar to 6 bar. That's another thing that you need to look. And check your oxygen supply daily for purity with oxygen analyzer on the centralized system and on the cylinder itself. Battery alarm precaution. This is another common issue that you're going to see. Battery issue, power source issue. Because the power source is not stable, all this, you ended up going to get power failure and battery not charged properly and battery not working properly. So the solution is always plug in into a proper correct voltage and use a proper secured power cord. Check the battery level before connecting. Charge should be carried out regularly. Basically, you have to charge regularly and make sure if the battery is charging properly. And always remember, lifespan of the battery can be 1 to 2 years. So you need to know whether the battery need to be replaced or not. So these are recommended by most of it. And remember, your ventilator is critical equipment, so your battery is play a very important role. If any power failure, the battery should work for a certain period of time. So make sure that this particular precaution need to be handled carefully and make sure the battery is there, because these are life-saving equipment. Anything goes wrong, it's going to affect the patient. So when you talk about clinical user precaution, always make sure to do self-tests with the ventilator they're going to use. Properly trained personal use only, and the important thing is that the person should know about the ventilator and familiarize staff with the operating manual before using on the patient. So remember, you got few brands, each brand and the ventilator function is the same, but the way of operating can be different on the screen. So you need to know all that. And one manufacturer manual may not exactly match with others. So if you got brand A, brand B, brand C, the manuals can be different. So you need to know your manual. So monitor the function state of the ventilator while in use. Familiarize staff with the alarm system. Always remember when you got alarm, always check what's the, what the cause of the alarm. Do not move as you wish, and do not place ventilator in unwanted area, heat, all that, because if you got cylinder all to this on this device, it can be hazardous, can be explosive, all this, because you're dealing with oxygen, all that. So you need to be careful with that. So when you talk about BMET precaution, always remember qualified personnel should undertake the service. So the thing is, you should know your ventilator very well, and get to know with the manual, all that. Follow the test specification mentioned in the service manual, or follow the checklist properly. So you need to know your method of um, checking all this, and perform general service at regular interval, typically every 3 months or 6 months, depends on the use and manufacturer recommendation. Because these are critical equipment, it can go under every 3 months or 6 months, depends on the condition. And always run a test, self-test, and calibration before using the ventilator for further testing. Ensure the ventilator pass all the tests, and once everything is good and the ventilator testing, everything is passed, then only you can pass it to the clinical user to use. Until then, don't put them into the service. Alarm. So you got high pressure alarm, low tidal volume alarm, and apnea alarm, all these type of things. Okay, the key important thing is never ignore an alarm. Find out what's the reason of the alarm. Refer to the user manual. Do not mute alarm regular basis. Find out the source of the alarm, why the alarm appear, and try to troubleshoot that particular issues. Low alarm, it can be low pressure, low tidal volume, apnea, and patient circuit leak. These can cause low alarm as well. Very important, check, remove the inspiratory bacteria filter, external oxygen sensor, try another patient circuit, because sometimes patient circuit can be leaked that you don't know, and block the outlet of accelerating flow sensor while running the leakage test. Some of it depends on the brand and model, but you can do this. If the leak stop, replace the acceleration valve, verify that connection between the oxygen flow sensor and oxygen valve is tight, because there's a O-ring. The O-ring may be broke, so you need to check that particular thing. So inadequate flow, check with the analyzer and calibrate the flow sensor. So what happens is your patient data and your setting look a lot of difference, and your outcome on the ventilator analyzer look different. So what happens is your setting is 500, but your patient data showing 700. So, and your ventilator analyzer showing 600. So 500 means the tidal volume plus minus 10, it should be somewhere 550 to 450. But if you're showing 700, that means something wrong with the flow. You need to check that particular part. Sometimes due to the wet circuit on the flow line, or at the same time, the flow sensor need to be calibrated. Low inhaling pressure. So same thing, check the patient circuit leakage, verify the O-ring on the oxygen sensor, and the transducer, pressure transducer, and check the connection between the inspiratory manifold and inspiratory out auto zero, the solenoid. It depends on the brand or model. Check the kink or cut in the tube between the inhaling auto zero and solenoid and inhaling pressure sensor. So this for low inhaling pressure issue. High peak pressure alarm. Normally the problem can be the measurement peak inspiratory is greater than the set value. It can be very high because increase of airway pressure, high pressure on the incoming driving gas. So it show high pressure alarm, high tidal volume. So when you get this type of problem, always check for water in the tubing, clean and replace with a new tubing, and a filter block. Basically, there's a filter that has been used, is blocked, and you create more resistance, and water trap is problem, and partially or completely blocked tubing, kink tubing, and replace. You need to replace this to get smooth connection, and check and reduce high input pressure in the ventilator system. So you got high pressure, check on the incoming pressure as well. So all this need to be done. This is the solution that you can look into it. Okay, we're going to talk about.
I'll go first, and then Gurna, I'll let you explain some of the challenges that they faced.
Yep, that's the thing. I'm going to pass it to you, Erin. Thank you.
So we wanted to tell you a little bit about what some of our teams in Ethiopia are doing. They're partnering with Ethiopian Airlines. It's sort of the national, airplane system that they've got. What they're doing is they're actually transporting things like ventilators, things like oxygen concentrators, and they're taking them from all over the country and bringing them to one central location. Actually, I think two central locations. They're both universities. One is for airline technicians, one is for metrology. But they're creating these sort of warehouses where teams and volunteers can come in and do preventive maintenance. They can do corrective maintenance. You can see all the checklists that they're filling out here. They did about 24 ventilators in the first week and a few more since then. But we're going to tell you a little bit about what they've struggled with so far, and a little bit about what they've done to solve those things. So Guna, I will go ahead and give it back to you.
Okay, these are what, as Aaron mentioned, the challenges and the thing that they went through during the performance test verification. So when they do performance verification test, PVT, that's things that you need to do is electrical safety test, running the extended self-test, EST. So self-test on the ventilator itself, conduct parameter testing by using ventilator and setting up the ventilator with the ventilator analyzer, sensor verification, calibration, and flow sensor and oxygen sensor. What happened is these are main component that they're going to do during a performance verification. Challenges that they have is test lung. Some of the test lung too old, so ended up not going to give a proper pressure and very sticky test lung. And analyzer configuration. So when you talk about analyzer configuration, is on the ventilator analyzer. You always have to look into ATP and BTPS setting, all this. At the same time, the driving gas play very important role. So your driving gas, if you're running with oxygen, you need to set the driving gas. And if you're running with oxygen and air, you need to set both together. If you're running with air, you need to set on air. Okay, when you talk about altitude, Cambodia is almost same level with the sea level. So altitude doesn't affect much, but in Ethiopia or in East Africa, basically the altitude is quite high. The highest can be 3,000 meter and some point 2,800 meters. So when you talk about altitude, your pressure, your oxygen level, your boiling point, all these change. And this is very important that on your ventilator itself, that's before you do installation, you need to set the altitude pressure. So you need to set the actual altitude of your location. So when you set all these, the ventilator understand that when altitude change is going to perform according to that altitude. Flow sensor calibration, that's another challenge that you need to know. And patient circuit, also very important. So these are challenges that you're going to see or things that they went through in Ethiopia. Electrical safety tests, you're going to test according to the IC 60601 standard. Everyone know all the medical equipment followed according to this standard. So you're going to measure line voltage, device current, resistant leakage current, normal condition, I used to call it NC, normal condition, and SFC, single fault condition, enclosure leakage current, normal condition, and single fault. So when you see on the connection here, these are measuring resistance. So at the back of the ventilator, you're going to see the equipotential of the ground connector. So you have to connect that, and the power supply are connected to the on the electrical safety analyzer, and these particular cable are connected with the ground, and you're going to measure resistance and should be below 0.2. So you got 0.09, that's a good reading. So when you talk about running extended self-tests, these are tests that you do above the actual normal self-test. So you need to enter diagnose mode. These are examples showed on Philip B200. This one of the ventilator that they did calibrate and did the self-test, all that. You need to go into the mode by pressing the alarm reset with the 100% oxygen thing. And very important is never use ventilator if does not pass the EST. So make sure the ventilator pass the self-test, and in the ESC, if the ventilator pass the self-test, you don't need to do the extended self-test. But if the ventilator failed the self-test, the normal self-test, then if your flow, all these not matching, you need to go to the extended self-test. So when you do this type of testing, don't intend to connect to the patient. Remember, as a biomedical engineer, you are not working with the patient, you are working with the machine. So you always check the machine properly. So when you do extended self-test, make sure that you check the pressure and the setting, whether adult, all this, and you do the connection. So when you conduct a parameter setting, so you are talking about setting up, checking the altitude setting is correct or not. Make sure you write down all the details. Once you check all this detail and you go to the diagnose mode, user configuration to set the altitude. For example, showed in this particular unit, B200 in Addis Ababa, Ethiopia, the altitude is somewhere 7,726 feet. So you need to set that particular setting. So this particular information you can see in the Google. So when you type altitude of Cambodia, for example, Phnom Penh is going to show you what's the feet look like from the sea level. So these are very important. And some analyzer, they got a barometer on the analyzers, on the ventilator analyzer. You can refer to that particular barometer and get the reading as well. So these are conducting the parameter testing. So if you're talking about setting up ventilator analyzer, using ventilator analyzer, it can be VT mobile, Fluke, or you can be TSI, like what you guys using in Calmet, TSI unit. So all these particular ventilator analyzer work exactly the same. It have BTPS, everything. So make sure you do the connection, the Y type connection properly with the filter, everything. Set the analyzer to ATP if you're doing pressure. At the same time, use BTPS to run the analyzer for doing the volume as well, so you can see the difference actually. Sometimes with ATP, due to the altitude issue, is going to pass, but certain country you need to know your altitude as well. BTPS will be the common thing that you use during your ventilation test, but like anesthesia, ATP is good enough already, but BTPS is commonly used on the ICU ventilator. So it depends on the setting. You need to know your ventilator itself running on what mode. Is it on BTPS or ATP, all that. You need to know that particular part of it. Okay, another thing, conductive parameter testing. So when you talk about flow sensor verification, you need to go into the particular mode and connect the ventilator analyzer as shown. Depends on the brand and model to verify the calibration, and run the particular unit with the calibration by using the analyzer. Set the analyzer to liter per minute setting. So every analyzer you can see the parameter that you want. So you set on liter per minute, set the analyzer to gas flow to air, because you are running with the air, you have to set on the air. Then touch the safety to energize the safety solenoid on the ventilator. Depends on the model. Some are using different type of key. These are fully followed according to the service manual. Check the set airflow and correspondent to measurement flow. So if your reading is out of range, for example, you are delivering 50 liter per minute and your reading is out of range in 10 to 20 cycle, then you need to go for a different procedure. You need to verify it first by putting a flow, like for example 30 liter per minute, and you see on your analyzer whether is it inside that particular range or not. So when you conduct the parameter testing, so your airflow is set 50 liter per minute and reading on the analyzer show 48.9. So you see you need to do the low flow until the high flow, and you have to go back to the low flow to verify. So oxygen sensor verification very similar, follow the same procedure using the oxygen button. Okay, so you need to go to the particular parameter mode and change the flow that you're checking. So it's, for example, you set 50, the range should be somewhere 45 to 55 liter per minute. So on this particular analyzer is showing 48.9. That means inside the range. So conduct a parameter, you need to do the I, for example, the I1, 100 liter per minute. Your reading is 95.3. We see on the screen of the analyzer, it's showing 95.3. And if you see the measurement range on liter per minute should be 90 to 110 liter per minute. So the reading is inside the range, and when you do this type of calibration, always remember do low, medium, high, and low again, and do the zeroing as well to check whether your flow sensor is working properly or not. Okay, when you talk about challenging part, I did mention about test lung earlier. So beware of the test lung. We've been used a long time. Sometimes you don't use it very long. You're going to get some affected measurement, because what happens is if the test lung never been used very long and kept it, the rubber seal going to become harder and sticky, and sometimes what happens is you're going to get the pressure reading completely different because the expansion is not good enough. So these are challenges that you're going to see. So analyzer configuration is very important, because if you do wrong setting, you're not going to get a proper reading. So make sure that's very important. ATP versus BTPS. That's 4 types of setting, depends on your analyzer as well. But ATP, BTPS is very commonly used. So you need to know that particular thing. And the altitude, make sure your altitude is correct. I'm not that so worried about Cambodia, but these are things that normally will be a challenge in a country that altitude is very high. So you need to know this particular thing here. And flow sensor calibration is very important to make sure that patient data and what you set up on the system have to be matched. So it's one of the challenge that normally you're going to see if you're going to do flow sensor calibration. So you need to, if the particular unit not working properly, this is one of the challenge you have to look into it. The volume is not delivered properly, but your setting is 500, but you get 700 something. So this one of the calibration that you look into it. Patient circuit, remember when you do testing, once you do the setting, all the connection should not using your hand to hold the particular patient circuit, because what happens is heat transfer can create resistance. For example, a heat transfer on the pressure line circuit, it can increase the pressure. So normally when you do all this connection, should not hold this particular connection. I think most of the training in Cambodia, when we did mention about this part of it. Okay, that's all. And these are some of the BioMET engineers that doing testing in Ethiopia. Thank you.
Thanks, Gunnar.
Welcome.
All right, so we are going to go ahead and open things up for discussion. At this point, you can ask questions about ventilators. If you have questions about some of the other devices that we've covered so far, you're welcome to ask those as well. But we really want to make sure that what we're sharing with you is relevant. So we'd love to hear any challenges that you guys are having with ventilators or other equipment. I'm also at this point going to launch the poll. That'll be, again, another opportunity for you to give us some feedback, let us know what you're interested in, and we can help tailor these things to you. It looks like the one question in the chat right now is where Guna got his haircut. That story.
After 63 days with the long hair, my wife said, why not cut your hair? So I ended up cutting my hair. It's too long.
So there you have it, folks. You can ask your wife or girlfriend. It's about as good as it gets right now during quarantine. Guna, I think in our session with our African participants, we had a lot of questions about changing drive gas, the process for converting an anesthesia machine to a ventilator. Can you remind everybody why you would want to do that, and also maybe a few reasons why you wouldn't want to do that for COVID patients specifically? We covered that a bit in our first session on ventilators, but it might be you here.
Okay, when you talk about driving gas, normally when you talk about ICU condition or any condition on the patient, when you're delivering gas, oxygen play very important role. But sometimes what happens is this particular scenario, they are talking about a condition that you don't have oxygen supply enough, so they're going to run air to support the breathing. That's all. But when you talk about COVID patient, oxygen play very important role to do recovery on your lung. Respiratory, you need oxygen most of the time.
That makes sense. And I think what we discussed in the first session was that you shouldn't be converting anesthesia machines for COVID patients also because of the risk of cross-contamination, right? There's fewer filters and they're not quite in the right places to go through all the tubing. So there's a much higher risk of transferring.
Yeah, because you have to remember the anesthesia machine is a closed circuit, so you ended up going to get infected on the line, all that. So that's very important actually. Try to avoid to do that, but if you don't have option, maybe you need to do that. That's another thing. Because ventilator is an overwhelming thing in the department. Maybe you're not enough ventilator device. You got anesthesia that can cause to do that particular changes. So that's another thing.
And in a lot of cases, you may be able to use anesthesia machines on actual ICU patients, whether they're coming out of surgery or some emergency, and then that frees your mechanical ventilators that you would normally have in ICU for COVID patients. But it keeps the anesthesia machines sort of separate.
Yes. Yeah, you can do it on the normal patient rather than a COVID patient. Because when you do it on a COVID patient, if you don't do a proper filter circuit, all that, you ended up going to infection of the closed breathing circuit. We don't want that.
Okay, again, that poll should be, if you're on your phone, there's a green bar at the very top of your screen, and you should be able to take it there. We have a couple people, but there's still quite a few of you who haven't submitted. There's also plenty of room if anybody hasn't. We're just a few minutes over the hour, but I think we can leave some room for that. If anybody has anything. Okay, well, I'm going to leave the poll open for a few more minutes, but I will end this session. Friendly reminder that we will be meeting at this time next week again. We're going to be revisiting oxygen concentrators. So if you want to leave us feedback, if you have questions specific to oxygen concentrators, feel free to leave that or email us. We'll mostly be talking about replacing zeolite. That's something that's come up quite a few times in some of our other sessions. And we'll go through all the details with that and a few other things. So let us know if you have any requests. And with that, I will leave you to the rest of your day. Thanks again for participating.